Now let's look at how to determine what sample size would be needed in a study in order to achieve a desired confidence level and stay within a set margin of error. This is a very real world type of situation where we want to go into a study knowing how to choose a sample so that we can achieve the type of accuracy that we would want. So we're going to look at how large the sample size n should be in order to estimate the population proportion p. Here is a review of the notation that we've been using so far. P is the population proportion, which is unknown. P hat is our sample proportion, which comes from sample data. N is the total number of values in our sample. Capital E stands for the margin of error. That's the distance between the center of a confidence interval and each one of the two limits. And finally, our z-score is our critical value, which is used to build the margin of error. In order for us to calculate the sample size needed to achieve a given confidence level and stay within a given margin of error, we want to use one of the following two formulas, and how we know which formula to use when is a matter of whether we have a sample proportion from a previous study that we can use as our starting estimate, or whether there is no previous sample proportion to use. So the two formulas look very similar. The difference is in that numerator. If there is a previous sample proportion from a study that has already been completed, then we use that p hat and q hat, its complement, in the numerator. If, however, we don't have a p hat value from a previous study, we use 0.25 in the numerator, and that 0.25 comes from the fact that we use 0.5 for p hat and then 0.5 as the complement q hat. So why this number is what we use when there is no previous p hat value is that by using a p hat value of 0.5, that actually gives us a more conservative number than if we had any other value of p hat. In other words, n will be as large as it can get using that conservative number. In terms of rounding, whenever we get a value for n that has decimals, in other words, it's not a whole number, we always will need to round up to the next whole number, regardless of what number follows the decimal point. So you're going to round up always. Here's an example where we got n equal to 708.135. Even though there is a 1 in that tenths place, we're going to still round up to 709 people needed for that sample. And that's because 708 is not sufficient. We need more than that. And so the next whole number would be 709. Here's an example where we have a Pew Research Center survey conducted in the year 2016 involving 4,787 U.S. adults, and they were asked if they shop online. 79% of them said that they do. If we want to conduct a new survey to determine whether that percentage has changed, how many adults must be surveyed in order to be 95% confident that the sample percentage is in error by no more than 3 percentage points? Let's unpack all the information in this introduction. First, we have 4,787. That is our sample size n. Secondly, our previous study said that 79% of the sample said that they shop online. That's going to be our previous p hat. Next, they want us to be 95% confident, so that is our confidence level. Finally, they want us to be in error by no more than 3 percentage points, so that is going to be our margin of error E. So let me summarize here below what we have. We have the value of n is 4,787. We have that a previous study had that p hat was 0.79, and we want our confidence level to be 95%, which means that our critical value z must be that 1.96 that we saw earlier in this section. And finally, they want the margin of error to be 3 percentage points. So we're going to write that as a decimal as 0.03. If you take a moment to make these notes to yourself, it'll be much easier to substitute the values into the formula to calculate n correctly. Now you might be thinking, but there is an n. It's right here. Now this is a previous study, and so that's not the n that we're trying to find. That actually is irrelevant in order for us to calculate the new n that must be needed in order to get the desired results. So here we have the formula. Because we do have a previous value of p hat, we're going to use the first of the two formulas. Again, our critical value was 1.96. That came from the fact that we want 95% confidence. P hat was 0.79, which makes Q hat 1 minus 0.79, or 0.21. And our margin of error, we're going to write as a decimal. 3% is equivalent to 0.03. And so we get 708.135 would be the sample size needed. And as we saw earlier, we always round up to the next whole number. I think this is quite significant that the previous study had almost 5,000 people in the study, but we really only need just over 700 to get the desired results. Why repeat the study with 5,000 people when we can get what we need with significantly fewer people? For part B, we're to assume that there is no previous study, so there is no p-hat value for us to use. That means that to calculate the sample size needed, we're going to use the second formula. And again, that difference is in the numerator. Instead of p-hat times q-hat, we're going to use 0.25, which is the same as using p-hat equal to 0.5 and then q-hat equal to 0.5. It's already multiplied for you. We see here that without that previous study, we will need more people in the sample to achieve the same type of confidence level and margin of error. In fact, we'll need 1,068 people, so that's over 300 people in addition to what we would have needed if we had that p-hat from a previous study. So again, using 0.25 will give you a more conservative, also known as a higher value of n, oftentimes more than what you would need if you had some additional information.